So once we, we keep the measurement in what? Metric. Once we are done with that, we need to set up our vehicle. We're going to use the same vehicle parameters of the drone to set up the vehicle in there. So here, the firmware we are using is Pix4 Pro Vito. I'm sure when Jed did the installation, so if it was a fixed wing, we would have changed this one to fixed wing. If it's a multi-copter, we'll change this one to multi-copter. So it's a Pix4 Pro Vito. It has already been set for you, but for the purpose of knowledge, you always have to set up the vehicle yourself. The cruise speed and the hover speed of the aircraft is 16 meters per second. Please do not change this. This is what the manufacturer has set to. But when we start operating on the controller, you can use the knobs to increase the speed. So we keep it at 16 meters per second. So let's all bring our attention to the ground control station. I'm going to delete whatever I was doing previously. Okay. So first, let's look at the entire surface. I'm going to go around it and then explain every single tool here. So the first is this bar we have here. So this bar shows the terrain height and your flight height. So whenever you are planning your mission, you are able to see your terrain height as well as the flight height. The flight height will be orange and your terrain will be green. When you happen to fly your drone, you need a maximum of 50-meter clearance. So let's assume this is my, I have my terrain looking something like this. My flight height will always have to be above this. The moment I have my flight height and I have a terrain that goes into it, the line will change from green to red. Because that means that there's going to be some crash because my terrain is higher than what? My flight height. We're going to look at all that. So that information will be depicted here. Whatever height you are flying, how you are changing your pitch, angles, depression, everything will be shown in here. You can use the plus or minus to zoom on everything that you are doing here. Okay. Now the next tool that we need to understand is the mission command. So whatever mission that we are going to create will be displayed here. So if you put in takeoff, landing, everything will be here. And this is where we can also edit the mission. So the mission command and the mission command editor is on this side. So when you hear me say, let's go to the mission command editor, we are coming to this block here. And then we have our statistical toolbar. So our statistical toolbar contains all the information regarding our mission. So our flight speed, our height, our angle, the time that it will take for the mission to be completed, the distance from where we took off, the distance that the drone will cover, everything will be showed up in the statistical toolbar. Now, this is the planning area. You have the planning area. This is where you plan your mission. After planning your mission, you now click on the upload button to upload the mission onto the drone. But before you upload, you need to save the mission and go and validate it and make sure that it is correct before you upload it. Now, assuming you have uploaded the mission, once the mission is uploaded, you come to your fly button here. So this is where you have your action toolbars. So these are your action toolbars. So when you come to your fly, the mission that is on the drone, you can see it. And then you can issue the command for the drone to take off and go and execute that instruction. Okay. Now, the very tip here, that is the Qground Control symbol. Upon clicking on it, opens up the advanced panel or the menu panel. And this advanced panel contains 3 sub-parameters. So we have the vehicle setup, the analyze tool, and what? Application settings. The vehicle setup, so when you are building these drones, normally when we are building them in the lab, you have to set it, you have to program it or set it up. And when you click on the set it up, you have to set up your sensors. You have to set up your sensors, set up your airframe, set up your radio, set up your flight modes, your battery parameters, safety, cameras. So when you look at this one, this is the vehicle, you have your sensors. So if there is any issue with the sensor, compass is not happy, GPS is not happy, which it could be due to fuel cost or whatever it is, chairman will move from green to red. This chairman, he's not happy. If it is radio controller issues, he will also not be happy. He will ask you, please calibrate me. I'm not happy. Flight modes, the battery system, the safety system, the camera system. So anything about the aircraft, when you are setting it up, this is where you come and then you set it up. The manufacturer says that you don't need to play here, so you don't play there. It is for them. But you need to understand what is happening there so that you can respond to any issues with their support. So firmware here, the airframe, the sensors, the radio, the motors, everything comes here. So let's go back. Now the next one to look at is the analyze tool. So with the analyze tool, this is where you download your log files. I mentioned that we have 2 types of log files, right? The bin file and what? The T-log. So here you can refresh. Once you refresh, the logs that is stored on the drone will what? Come here, and then you can click on any of them and then download. Once you download the log, you can use the log to geotag the image. So for the surveying and mapping, this is where you do the geotagging of the images. You also have the Mavlink Inspector, which is basically checking the communication quality. So if there's any communication or any channel interference, the Mavlink Inspector will be informing you. I remember one of our works at a mining company, we went there to map and we're having a lot of signal channel interference. So I wasn't on the field. It was Max and Jerry. And then they upload the mission, the drone will take off, it will go doing the mission, and then all of a sudden, signal interference returns to line, and the drone will just abort the mission and come back. That whole day, they couldn't fly that area. It was a tailings dam. They couldn't fly that area. And then they called back and said, boss, we are having issues with interference. So I said, okay, let me look at the Mavlink Inspectorate. So the Mavlink Inspectorate had outputted certain parameters. At that time, I didn't understand what those parameters are. So basically, it outputted a certain error code. And that error code, you have to interpret it to understand what that error code means. So I one of the things that I do, I copy the whole error code, place it on Google, fine, because I'm not the first person to have that problem. Come again. Yes. You are not the first person to face that problem. Somebody may have faced it and found a way around it. So I copied that problem and then I pasted it on Google. I got 0 search. I reached out to the manufacturer. The manufacturer even came in, did an update on the system, still we're having the error. The drones were not flying. 2 days are already gone. Hotel bills are piling up. Daily allowance are piling up. Workers, they don't have any hat around those areas. You sent me on the job. I am there. The longer I stay there, the longer my money increases. This manufacturer couldn't help me. So I wasn't on the field, so I started interrogating them. I asked them, do you have some cell tower around? They said yes. Do you have some machine shop or machinery, something around? They said yes. I said okay. The problem with mining environment is that they have exposed a lot of metals. Because of the digging, they've exposed a lot of metal. So if you have any physical metal being mounted there, the electric field from the metals also transcends into any tower. Any metal there also kind of have some metal electric field, magnetic field around anything almost there. So I said, okay, then since we have divided the area, move away from that area and go and map the ones that are further away and let's see. They went there, the thing didn't do that again. So it was the tower and the things that were around that were causing the interference. And then they just moved the drone. The manufacturer came in, he didn't even know what the problem was. But that is where little local knowledge and community learning building is very important. I always tell people, or people always kind of try to tell me, Kofi, if you teach everybody, who will give you business? Somebody told me this, if you teach everybody, who will give you business? But the thing is that if I don't create a platform so that I share my problem, we solve it, and maybe somebody also shares the problem, how do we strengthen the knowledge base? And that was how we solved. They just moved the drone to another location because we're having magnetic interference. And it was this mission, Mavlink Inspectorate, that was outputting that error. I didn't understand the error. Copy the error, put it on Google. Google didn't give me any result because. But the moment we solved the problem, I posted it in the discussion group. This is how we solved it. So if you happen to have this error code, this is what you have to do. The funny thing about the drone engineering platform, anytime anybody goes to read about your article, you get an alert. Somebody has read it. Then you know that you are becoming a champion. The problems are hitting there. Vibrations. So vibrations are basically caused by mechanical movement. So you can have certain parts not really tight well, like the knobs, the motors not mounted well, and once they are like the aircraft is taking off and these parts are loosening up, vibrations will start setting in. So when you look at the vibration graph, there is the allowable vibration and the non-allowable vibration. So the moment you start getting those issues, then you need to really do a physical check on the mechanical aspect of your aircraft. The next one is the application setting. And this is where we will start from. So with the application settings, you have the general area where you have your minimum altitude and then your maximum altitude. So you can elevate your maximum altitude so that you don't have any altitude cap. You see, civil aviation will cap you, but you have the freedom to, because you have 4,000 meters to play with. So here, I'm going to set my maximum altitude to 500. You have your go-to location maximum distance. So the go-to location maximum distance, when you pre-plan your mission, you can, let's imagine there is some piracy activities happening. They radio in, they've given the coordinates. You can just input those coordinates and say go to. The aircraft will just fly directly to that coordinate. Or you can see it on your map. Or you can see the video feed on the map. You can just click and go to. And the drone will move from the course and then go to that course. When it gets there, it will be circling around for you to be picking intelligence. So you don't necessarily need to be worried about the aircraft. The aircraft will be flying. But you now have to control your camera to be picking intelligence. Once you are done picking intelligence, you just instruct the drone, get back to course. Or get back to your flight path. So when you look at some of the, for example, Obuasi Mines, what they have done regarding their concession patrols, they have predetermined routes that they fly on specific hours for intelligence gathering. So once they are airborne and they are monitoring those routes, if they see any galamsey activity, they just click on the screen, and the drone will be circling while the camera keep focus on them. When they start moving, they start clicking, and then the drone will what? Keep moving until the ground team moves into action. In certain instances, you can mount the second screen in the patrol vehicle and give them a live feed. So whilst the drone is in operation and the pilot and the others are operating it, the patrol team also gets live feed of the action that is going on the ground. So you don't also move in blindly. So that is the purpose of the second screen. So this is where you change your meters. If you have not done that, you can do that. And then we have different map providers. We have different map providers. So depending on whatever map that you want to use, Google Terrain, Google Satellite, Bing, you can change that feature here. So if you want Google, you can put it in Google. And then if it is satellite you want, you can change it to satellite. If it's the street you want, you can change it. So let's say I'm using satellite. You have your zoom range. And then once you are done with that, you have the path where you want to save your mission. So you can change it. You can set it to maybe your own folder on your desktop where you want to save. And then also your telemetry log. You can set to save it after every vehicle, after every mission, you should save it. And then the drone should connect to all of these communication infrastructure. We are not using an RTK system. This is a surveillance system. So if it's an RTK, you check that place. And then you have the IP address, the ADSB signal. And then, so here, when we set up our aircraft, we'll come back to this one and then set up the ADSB. The next is the communication. So we'll just jump that for now. And then we'll go to offline maps. Now, offline maps are very critical. You may find yourself in certain environments where internet connectivity is very difficult. So as part of your desktop planning, you can pre-plan the mission in your office where you have good internet connections. And you can cache the map before going to the field using the internet. So that is where you do that. So if you want to do that, it's very simple. Let me just delete a few of these. So if you want the offline map, you click on the Add New Map Set. So you click on this one. Now, this is the area we plan to take up. But what I would advise is that you can change the different service providers to see which one is very updated or which one is modern, or because some of the maps can be 4 or 5 years old and there may have been a lot of changes in that area. So here I'm using Google Satellite. If I notice, maybe you guys should also pay attention. If you've noticed there is some changes that have not been captured by the map, you can click on a different satellite provider. So here I'm checking Bing Satellite to see the difference. So it will take a little bit of time. It's using the internet to update the map. Yes, sir.
In case you are going to go to the field, if you have to fly, then you need to have your money on the tablet.
And all these things are on the tablet. All these things are on the tablet. So the tablet, you do the hotspot with the 5G to it, and then you go and then you cache the local one. Cache it.
The internet is only 5 gigabytes.
It's only 5 gigabytes.
Only 5 gigabytes.
No, 5.8. This is not like 5G internet. Let's be clear. It's a normal, yes. Yeah, normal. It's a normal Wi-Fi. But we have two different carrier units. We have the 2.4 and then we have the 5.8 gigahertz. So if I go to your hotspot, let's do a quick exercise. Let's everybody go to their hotspot. When you go to your hotspot, you go to hotspot. Yes, and then you go to yes, you go to the AP band. When you click on it, you see the 2.4 and the 5.0 gigahertz band. So in this case, you switch it. So sometimes certain laptops, when you are using it, you do the 2.4, you don't see the SSID, but when you change to 5 gigahertz, you see it. As iPhone. iPhone doesn't have check for iPhone, the AP band. You do also iPhone. You have special. So this one you change it to this one has some internet to the. So you have it's iPhone. No problem. iPhone. No problem. Because we can't iPhone. And that's the problem. You have some problem. Is that what about you? You know that. Is it open? So once the data is loaded, so you see that the data side it's downloading here, it's loading here. You have the what we call the zoom level. So we have the minimum zoom level and then the minimum zoom level and the maximum zoom level. So assuming this is what I want to see on the ground, I will have my maximum zoom level and I'll have my minimum zoom level. So I will recommend 19 and 13 just to get enough details on the ground. Once you are done, click on the fetch elevation data to fetch the Google elevation data. So you have the base map plus the elevation information. So once it starts downloading, and then you click the download. The feeling like network is not really good in that right now. So you can change the manual service providers. Network is not really good. So, you know, the bigger the area of your focus, the bigger the data you have to download. Maybe I should have mentioned that. I'm seeing some are having 1 gig, 2 gig. You not download, you not finish now. Just focus on a small area and then let's work with it. So with this done, you have an offline data. So even when you're on the field and you don't have internet, you will not have any issues with your map. Yeah. And you can see that the map is built in tiled layers. Yeah. So as you are zooming in and the internet is getting better, then your data is kind of settling in. So be a little bit patient with. Can we go on? Okay. So now with the environment set up, we've cached our offline map. We're going to start our mission planning. The first thing to do in terms of our mission planning is to set up our takeoff point. And the takeoff is made up of 2 parts. So we have the takeoff and the transition distance. The recommended takeoff height by the manufacturer is 60 meters. The transition distance is 300 meters to 800 meters. The takeoff and the transition has to be done into the air. What is the meaning of this statement? It means that every time we want to take off, we need to find a direction in which the wind is coming from. So we always have to fly into the wind. So if the wind is coming this way, we don't fly this way, we fly this way. Okay. Now, please answer why. We touch you. Why do we need to fly into the wind? Give him the aerospace definitions. Give him the aerodynamics, the air pressure building over the. Please, he needs a proper answer.
So when you fly into the wind, because of the shape of the airfoil, and that is what determines the flight. When you are in fixed wing, it is the airfoil that you use to fly. So you have to fly into the wing for the wing to have that. For the wing to move over the airfoil to give it lift, in order to sustain the flight.
When you have good students, you are very confident.
I just as you follow it's very key, especially when you're flying fixed wing. When you're flying even quadcopters and your drone is facing the direction of the wind, sometimes you have to
And it can even slow it. But in fixed wing, it's an advantage for it.
Those make sure that you're always facing
Or the pressure difference between the wind that is going on top and the wind that is going under, that pressure difference is what builds up the lift component. So in fixed wing, it's only a small amount of power. It is the wing that is actually doing the lifting. And there's one thing about this design that makes it very efficient. When you look at the wings, it has this wing tips. It has these wing tips. Even the airliners have these wing tips. I think there's an assignment. Find out why airliners have wing tips. It was one of the marvels of aero aviation. Just this thing has done something to aircraft. Likewise, drones. Okay.
Previously, they were not like that.
Yes. But this has really improved aircraft performance. Okay, so take off 60 meters, transition distance 300 to 800. Please, you cannot come below this. And then we have to fly into the air. We already know the air resistance. Okay, so the manufacturer is saying 50 kilometers per hour. So if the air that is coming is more than what the drone can take, it will have issues on the aircraft. Okay? So that is the first part. Now,
confirmation.
Yes, please.
So for this drone, if you are going to start a mission and the wind speed around us is more than 50 kilometers,
don't fly it. It's just like you are traveling and then there's a delay at the airport because they're telling you the weather is not good. This one too, the weather is not good.
So you mean the in-air weather is when the wind speed is more than 50
kilometers per hour, you don't fly. But that is the requirement. Beyond this to affect the aircraft. So it's just like the manned aircraft. When the weather is not good, you are waiting for the weather to get better. Yes, please.
So based on the thing of lines, maybe the wind speed have a different from the ground wind speed. So you need a tell what's happening.
So you have a tool that can tell us what is happening. Yes. So we're going to use that to pick up those information. Well, as you are here right now, you cannot tell where the wind is even coming from. You can't tell until we use that tool to validate that we can't tell. Now, once the takeoff transition has been set, the next thing is for us to do a few clicks, depending on, let's say, we are designing a regular patrols along our harbor. So we have certain areas we always go to because of certain activities that we want to keep track of. That means that we need to set our waypoints. So that's the second session. We set the waypoints. So the waypoints is also made up of you giving it a height and then an angle. So we can so let me do a small 1D sketch. So let's say this is our home point. We took off to 60 meters. And then from 60 meters, we transition. Our transition distance, let's say 310 meters. So our multi-copter or our copter session was here. Now, between this angle here, that is 8 to 12 seconds, the vehicle now has to transition into a fixed wing within that 8 to 12 seconds. So the multi-copter motors will support that transition. It will not fully go off upright or immediately. It will support that transition until the fixed wing momentum is fully established. Then once that is done, our drone now will climb up to this waypoint. So let's say this is waypoint 1, right? So from here, 60 meters, my waypoint 1 will be maybe 90 meters. 90 meters. Okay? Now, the angle between these two, that is, when I get here and I'm climbing to here, is very dependent on this altitude that I want to go. So if I take off to 60, and then I move all the way to 500, I have a bigger angle. If I do 90, I have a smaller angle. But bear in mind that we have plus or minus 10 degrees to play with. So that plus or minus 10 degrees have some kind of limitation in terms of altitude buildup. So if I want to go to 500 meters, it is very bad for me to move straight from 60 straight to 500. Rather, I can build it up by keeping my pitch within the plus or minus 10 degrees. So maybe I can move from here to 90. From 90, I move to 200. 200, I move to 400. And then in that order, then I get to that cruise point, which is 500, and then I keep being in that altitude. We will see this when we start doing the simulation. Now, so this is my other waypoint. I do another click here. So this is the second waypoint. This is maybe 90 degrees, 90 meters. Between waypoint 1 and waypoint 2, because they are the same distance, the angle will be what? 0 degrees. Because there is no change in what? Angle. The same height, sorry. So if I'm flying, let's say, I come like this, go this way, maintain a little bit, come this way, go this way, and maintain a little bit. This is my positive angle because I'm changing. Sorry, this is my negative angles because I'm changing my altitude more towards the ground. And I'm climbing, and this is my positives. Okay? If I keep within a certain altitude for a long time, and there's no change in altitude, my angle is still 0. But whatever we do, this is our guide, plus or minus 10. Okay. Now, let's say that I'm done with my few clicks. So I kept my altitude at 90 meters. This is my last waypoint. And this is where I want to come and land. The landing component is made up of two components. We have the launch or the landing sequence, and then the landing stop. So when I click on, or when I put my landing here, or let's say, I say after this waypoint, bring the aircraft back and come and land. What will happen is that from my 90, the aircraft will approach my landing spot. The aircraft will loiter from 90. Because let's say I'm assuming that I want to land the aircraft at 30 meters. So let's say this height. So the aircraft, in order to lose the height from 90 to 30, it will loiter coming all the way from 90, go through 60, come through 50, and then it will now try to dummy the 30 meters and then bring the aircraft to home. If this was 200, it will build from 200, drop, drop, drop. But this loitering is a way of reducing that power and approaching the aircraft to that landing spot that I want to get the aircraft. It will do it somewhere before coming. It's not coming to loiter here.
But that will be close to the landing site.
Yes, close to. We will see it. So, and we need to keep a specific radius because we need to give the aircraft enough room to turn. If it is not given enough room to turn, it will bank on itself. Right? So let's look at a few examples and then we'll see how to go about it. So let's assume this is I'm trying to pick a few. So yesterday the driver, I want to see where the driver kind of parked. Oh, internet. Yes, yesterday, where did we come from? Like here.
No.
So, we now know the first one, someone here.
Yes. I remember. So we drove through like this, and then we came this way. So let's assume this is my launch. So the first thing I'm going to set up my takeoff. So I'm going to put. So this is my launch, and this is my transition, right? So it takes off, and then it transitions. Now I'm going to set the vertical takeoff to 60 meters. And then, so pay critical attention. So you realize that I have the green line and then I have the orange line. So this is my flight height and this is my terrain height. We always have to go above your terrain height. Okay. Now, my transition distance, as you can see, let me use the magnifier. So assignments will be put into the groups. You will do the assignment and then you will submit your report. Okay, so this is my transition. Now my transition is at 300 meters. By default, that is what is recommended. Now, once I'm done with that, I'm going to click on my waypoint. So I have this waypoint here. I want to go across the sea. Come back like this, and then finally I want to land the aircraft exactly where I took off. So I click on the land and then I click here. Okay. Come again. Okay. So let me go over again. So I'm deleting everything. Okay, so the first thing is the takeoff. So I click on the takeoff. And then once you click on it, you get the launch and the transitional distance. Okay. Now, my altitude is 60 meters, so I change the 50 to 60. 60 meters. Okay. Now I go and click on my transition. Transition heading, we leave it as it is, because right now we cannot determine the wind direction now. Okay, but at least with some pre-knowledge. But I don't want us to use that pre-knowledge. I want us to go through all the tools, and then we'll see how we can. So it's pointing, and it always points towards the east. The simulator always points through the east, but that is not the real direction. We have to work with the wind direction. Now, once I'm done with the transition, so I'm assuming I have takeoff. I've got to the takeoff height. I'm doing the transition from the launch to my transition. So the next thing is to add my waypoints within the surveillance area or where I want to work. So I click on waypoint. When you click on it, it goes yellow, and then you start clicking anywhere on the map that you want to fly to. So I click here, 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 and then I come back here, so I'm doing like 7 waypoints. So let's say I'm at the 7th waypoint, I want to land. I just click on the land, and then I click on exactly where I want to land. I want the aircraft to come to exactly where it took off. So I click on this, and then the moment you click on it, it pre-plans its land path. It pre-plans its land path. Now, so I want to change. So I've done the 60, I want to move to 90. So I want to change my altitude. So I move it to 90. Now what I want you to do is observe how these lines are going to change. So if you notice, because by default everything is 60, it's a straight line. And then the landing comes this way. You see, it's an approach landing. It drops altitude gradually and now descends. So now I move my first waypoint to 90. So you see, the moment I did 90, look at how it kinked. But look at something here. My gradient has now moved to 28. I'm outside the plus or minus 10. So let me move this one to 90. Come again. So is the gradient that we monitor, the gradient that is a plus or minus 10. Yes, also reduce.
So in such cases, you make you widen the distance between the.
So that the aircraft have enough space to transition.
That also depends on the terrain.
Yes, so that's a lot goes into getting a perfect mission that meets all these requirements. So you see here, I just made transition to waypoint 2 very short. And look at the gradient. If I should change this a little bit, you see, watch the gradient change. You see? The gradient completely changed because of distance. Because the aircraft has enough time to gradually set in. But sharp dips, sharp rise, these aircraft don't like that. So I would so these are just a few examples. So now you go through each waypoint to see whether it's meeting the requirements, right? Let's assume I've just done something. I want to pass it through the validator, right? So the next thing for me to do is go to Files and then save my mission. So I click on Save As, and then I'm going to give it a file name. So Naval Training Test 1. So I will save that mission, okay? Now, once this mission is saved, the next thing for me to do is to...
So you have to save the file. Say save as.
Yeah, so use the Save As and give it a file name.
It's telling me unable to save.
Why is it telling you that? Okay, so now with the file saved, I go to my browser and then we launch the I go to my browser. You can use I'm going to go through the validator again. So I click on the select flight plan. I pick up my flight plan. I set it to tomorrow. I'm flying at 10 in the morning. And then I validate it. You realize that the same errors came up. Okay. Now, when you come down here, there is a mission statistics. Please, I will be very happy if you get this once and for all. If I can get your attention. So the first thing here is the elevation profile. So the flight that I'm doing, look at that is the profile. You could see it's not the best. From here, I'm climbing all the way here and then coming here. And even though my terrain is literally what? Low. So I need to plan my mission well. Now, let's look at the mission statistics and checklist. The first thing, I passed my home point, the date, but the wind conditions here, I'm getting some warnings. The wind direction is 190. Now, for me to really visualize how the wind situation will be like on the drone, let's say maybe tomorrow, I can click on these wind details and it will open a software called Windy, which has been integrated into the drone. So Windy can give you about a week wind prediction of the area that you want to fly. So it's going to load up. You see the direction of the wind, you see the speed changes, within that area, the wind conditions there. So here you can see the various days and what will happen in terms of it's loading up. So whilst we wait for it to load up, I come here and it's telling me that my the ground speed I'm still having some warnings here, so I didn't pass that one. No fly zone, I don't have any issue. The estimated flight time for the drone is around 4 minutes. The total distance is 3.86 kilometers. And the flight speed is around 11 kilo per hour. So it should cover that in a very short time. Let's wait for... okay, so it's loading up. Now, this is the direction of the wind, 190 degrees. So this value here, I have to go back to my mission and do certain corrections. So the first thing is to look at my landing. So I change the heading to 190 based on the calculated wind direction by the validator. So I change this to 190. And then I go back to my takeoff. Now, I have to now hold my transition and keep changing my heading to 190. So I go this way. You see it's changing. Okay. But you could see my distance is no longer 300, so I have to now change my distance . So I have met my 190, at the same time I've met my 300 transition distance also correct. So let me just update this and then go and check again with the validator if that problem has been cleared. So I go back to my validator, I click on here to restart it. So I load the mission back again. So I'm flying tomorrow, and I'm flying at 10 in the morning. So what you see here is that the issue about takeoff into the wind direction has been, the problem has been solved. But I still have the slope, the gradient problem that I still have to fix. And then also the loiter radius, which is smaller than 100 meters, that I have to fix, right? When it's landing. So here, let's solve that problem. So I go to the landing pattern, I change the radius to 100 meters. So initially it was at 75. This is the landing altitude. So this is the altitude that the aircraft will reach and then do the vertical descent. Okay? So I've solved that problem. Now, the other error, it says that what? Just a second. The slope between waypoint 3 and 4 is 12.98 degrees. So waypoint 3 and 4, that is this and that. So how do I solve that problem? Okay, so let's see. I can either introduce an additional waypoint in between to balance it, or I can somehow manage it. So when you look at between these two, when I click on this X sign, I can put in another waypoint here. You see, between 5, so what I want to do is that I want to avoid this Abuaze plant because there's a pylon that is going around that. So keep my mission within the Bay Area. Okay. Move my 5 somewhere here and then manage my altitude. You can't see it. Okay. So now let me just update this and see if I have corrected the gradient issue. So I've saved it. I'm going back. Load the mission again. Tomorrow, 10, and then I validate it. So you have to adjust your mission with response to the structures. You get a pass, then you know that you are good to go. Yes. So you take off into the wind, you land into the wind. Yes, but it will come in the direction of the wind. So just like the way we took off into the wind, we land into the wind. So now that I have a pass mark, the next thing for me to do is to download the KML file and then place it on a 3D environment and see which obstacles are within my flight path. So I now click on this, and then this one will open in the Google Earth Pro. Okay, so it's going to load. So it's loading up. So now, when you look at the mission vertically, this is how it looks like. So we have our takeoff here. It takes off to 60 meters, and then it goes all the way. So this is the entire transition distance. And then after transitioning, it comes here, and then it hits these clicks, come back this way, 89. So you see how it loiters to bring in the aircraft. So it goes this way, and then finally comes back to land. This is what I'm trying to avoid. See, there's a pylons here. The pylons are here. So you can put markers on it so that you can see your buffer zone. So now, what we need to pay attention to is so you see that this whole place is 30. From here, it's reduced from here trying to reach the 30 meters. So we need to make sure that there is no obstacle within these 30 meters before it approaches the final landing destination. I know we are trying to do a lot in one day, so of course it needs some bit of. So I will end here. I will quickly use the time to put together the video, and then we will we'll just do a recap of it. But tomorrow we will put it in full gear, and then we will look at it. But this is where a lot of the work is. So if you are not feeling it, you should be feeling it by now.